Number 5. The graph shows a distant time graph of a cyclist who cycles towards the end of park and back to the starting point. Cycle to the end of park and back to the starting point. Okay. Which one describes the motion of the cyclist in the stated interval? 0 to 1, the cyclist is moving at uniform acceleration. I would like to draw your attention to this axis. Would you want to reconsider your answer? The distance time graph gradient is distance time graph gradient speed.
Okay.
1.1 to 1.5 is no. Okay, let's go through this. Okay, if I have a speed time graph, let me change color. Okay, distance time graph right now. So if it's distance time like that, means it's at rest. Because 0 second after 10 seconds, they are still at the same distance. So it's not moving, so it's at rest. Then if I have another case, which is like this distance time graph, and then we have a slanted straight line. A slanted straight line like this means the gradient is always the same. So we have constant gradient here. Then, and since I'd say here, gradient is speed, that means this represents constant speed. Then I can have another scenario where it's like this again, and the graph looks like this. So in this case, the gradient is always changing, and the gradient gets steeper and steeper. So in this case, this will be called increasing speed or non-uniform speed. Then we will have another scenario where it's like this again, E and T. Then it becomes like that. Then I measure the gradient becomes less and less steep. So this is decreasing speed. Oh, it's also a non-uniform speed. Okay. So with that, do you still want to reconsider your answer? Sorry, again?
B.
B. B or D? Can't hear you. Okay, correct.